Okay, everybody, today we're going to be doing a limiting reactant problem, and I'm going to try to explain as best I can exactly how you would go about solving this problem. Now, written here, we have the balanced equation of 4NH3 plus 5O2 yields 4NO plus 6H2O. And the problem given says a 2-gram sample of ammonia, which is the NH3, is mixed with 4 grams of oxygen, which is a limiting reactant. Now, how would you go about setting this problem? Well, what you would have to do is you would have to convert from both values, grams, into any product here that you have. So you would have to go your value 2 grams ammonium into into moles NH3, and then moles NO, and then and then grams NO. And you would do that the same thing with the oxygen, and whichever yielded less grams would be the limiting reactant. So we're gonna set that up right now. So we always start with our first value that they give us. Okay, so you have 2 grams, 2.00 grams NH4, or I'm sorry, NH3. Okay, and in order to convert to moles, we'll just set up our ratio using stoichiometry, and we'll say here, well, first we have to figure out the atomic weight of the compound NH3. So we would go to our periodic table here, and here's my periodic table. Here's my periodic table. So we know 1 atom of nitrogen is going to be 14.0067. So we go back here, and nitrogen is going to equal 14.01. We can say that. We can keep nitrogen as that, but just by rounding it to 4 significant figures. Alright? And then H3 is going to be 3 hydrogen times 3. So that equals hydrogen's mass, I know, is 1.0079 times 3. Okay, so we're going to do that on our calculator here. So the mass of 3 hydrogens is going to be 3.0237 or 3.0234. So the atomic mass of a molecule of NH3 is going to equal the 14.01 plus the 3.0234. And we're going to add that up right now. Okay, and that gives us 17.033. So we'll write that down here. Okay, so we have the atomic mass of NH3 in grams right here. Alright, so we go back to our conversion, and we start out with our first value, 2 grams NH3. For every 1 mole of NH3, you have 17.033 grams NH3, and that equals 1 mole. Alright, now you're going to now that you're in moles NH3, you still have to go to moles NO. Okay, so in order to do that, you have to do your conversion ratio, and you do that by looking at how many moles of NH3 per moles of NO. And in this case, both of them are 4, so it would be equal. So you take, and remember, whatever you're canceling out of when doing stoichiometry always has to be on the bottom. 4 mole NH3 to 4 moles NO. And then you have to look up the atomic mass of NO in order to convert into grams. So N we know to be 14.01 oxygen we know to be 16.0. So we'll add that up here with our calculator. Okay, so the mass of NO is 30.01. Alright, so in order to go to grams NO, we'll just do that conversion ratio, and we'll say 1 mole NO equals to 30.01 grams NO. Now when we do that calculation, see here, so it's going to be 2 grams times 1 mole divided by 17.033 times 4 divided by 4 times 30.01 divided by 1, and that's going to give us 3.52 grams NO. Okay, so we have our first value right there. Now we have to do the same process by using oxygen to go into NO. So our value for oxygen is going to be 4 grams. And this is pure oxygen, so in this case it would be O2. Instead of just adding up the mass for 1 oxygen, we would add up the mass for 2, because as you can see, the O2, alright, it's elemental oxygen, so you need to, in order to get the mass, you need to times that by 2. Alright, O2. So 1 mole O2 is going to be equal to, in this case, we know oxygen to be 16, so that would be 32 grams per mole. Alright, now we do the same conversion ratio. We're canceling out of moles oxygen and going into moles NO. So for every 5 moles, and you use that just by looking at your ratio right here, 5 moles, for every 5 moles of oxygen, of O2, we have 4 moles NO. Alright, you see our 4 right there. Okay, so now we're in moles NO, and we just do the same thing we just did right up here. 1 mole NO is going to equal 30.01 grams NO. And we do that calculation. That's going to be 4 grams times 1 divided by 32 times 4 divided by 5 times 30.01 divided by 1. And that's the 3 significant figures, so it'll be 3 grams. Okay, therefore, this is going to be your limiting reactant, because as you can see, this is 3.52 grams NO. Up here is 3.52 grams NO. Right there. And over here is 3.00 grams NO. Therefore, oxygen is our limiting reactant. Limiting reactant equals O2. And you see all we really did is we just used a stoichiometry dimensional analysis equation to cancel out. We cancel out of grams, we cancel out of moles NH3, I'm sorry, and then we were in moles NO, we canceled out of that and went into grams NO. Same thing here. We had grams oxygen, canceled out of that. Went to moles O2, canceled out of that with the conversion ratio. That brought us to moles NO. And then we canceled out of that into grams NO. And there you are. Limiting reactant problem. Any questions, feel free to send something to my inbox if you need practice. I'm glad to help.